Hey guys, today we're going to talk about scientific notation. So let's get right into it. The purpose of scientific notation is to make really big numbers or really small numbers easy to read. So you'll see when I'm talking about really big numbers, I'm talking about numbers with lots of zeros kind of behind the numbers. So you got 98 is your number, and then you got a bunch of zeros behind it for 98 billion, for example. And then really small numbers here, you've got a bunch of zeros in front of the numbers. That's what we're talking about here. This is a pretty good definition of scientific notation. Here's what we're going to do though, is we're going to take those zeros and kind of get rid of them. I say kind of because they'll still be there. What we end up doing is taking the base number without the zeros and multiplying it by 10 to some sort of exponent. So you can do that for really big numbers. The exponent you'll notice here is positive, or you can do that for really small numbers, and you'll notice here the exponent is negative. Please notice as well, sometimes you'll see the exponent here, the 10, as a superscript where it's kind of up in the top. Other times you'll notice this little caret and the 10. That's just a different way of writing it, but it means the same thing. Sometimes I'll do that when I'm typing stuff out, like on an online quiz, because it's a little bit easier for me to show that. And it's also a little bit easier to see the negative there. Remember, negative means small numbers, positive means big numbers. Those two things aren't very helpful. Let's move on here. Scientific notation. This is kind of the formula. So you'll notice in red here, I have a single number. That just means a number somewhere between 1 and 9. So an example would be 3. The number here could not be 10. It could not be 100. It couldn't be anything with 2 digits or 3 digits. It's a number, a single 1-digit number. Then you have the decimal. Here it's 0.45. This could be as many numbers as you want. It could be 1, 2, 3, 4. It could just be 4, 5, any number, any amount of numbers. Then you have the times 10, and then you have the exponent, which in this case is the 5th. That's how we write numbers in scientific notation. Everything here is mandatory. For small numbers, we put a negative exponent, and for large numbers, we put a positive exponent. Kind of mentioned that already. Okay, so quick quiz for you. The question is this number in scientific notation? Go ahead and give me yes or no for each question. Hopefully you were able to see that for the first one, yes, it is in scientific notation, but for the next two, no, they are not. The reason why is, even though all three of these guys are the same number, here we have 76 in front of the decimal, and here we have 769 in front of the decimal. You only can have one number in front of the decimal, and the rest of the numbers come after the decimal. So hopefully that makes sense. Up next now, what I want you guys to do is go ahead and take these numbers, and for the first two, they're in standard notation, convert them into scientific notation, and for the last two, they're in scientific notation, go ahead and convert those into standard notation. Great, hopefully you did it. For the first one, it's 2.8 times 10 to the 7th. For the second one, we're going to move it over 3, and then another 3, and then one more. Since this is a small number, it's going to be negative, so we get 4.63 to the negative 7. For these next two, we're going to have to move this first one. We'll move the decimal place over to the left twice to get 0.03051. So that's a small number because it's got a negative exponent. And then over here in this last one, we're going to move it 12 times. So what I think is going to happen is we'll have 10 zeros. Yeah, 3, 6, 9, and then another one is 10. Hopefully this makes sense. Each time what you're doing is you're taking the decimal point and moving it, and then just counting the number of times you move the decimal point. That's how you convert numbers into scientific notation. How to take them out of scientific notation is you're going to start where the decimal is, and then if it's a negative number, move it to the left. If it's a positive number, you're going to move it to the right to make that number bigger. Okay, the question is, can you convert from scientific notation into standard notation, or standard notation into scientific notation? Here's some more practice problems. Go ahead and try these out. For question 5, it's to the negative 4th. For question 6, it's going to be to the positive 5th. For question 7, we're going to move it 3 and then another 3, so that's the negative 6th. For this one, we're going to move it 3 times over, so that should leave you with 2 zeros in front of the decimal. And then over here, we're going to move it 6 times. That's going to give you 5 zeros behind the 7. Okay, hopefully we feel good about this stuff. Thanks for tuning in. I hope you guys have a great rest of your day, and let me know if you have any questions.